Alright, welcome back. We're on to a new section here, but we're still going to be dealing with the idea of logarithms that we've been talking about for a little while now. So, what's in this box, remember from the last section? We can write essentially the same equation two different ways. One of them involves a logarithm. Every logarithm has its own base, and we could write an equation this way. This is called logarithmic form, okay? And that means the exact same thing as this, written without a log in what's called exponential form. We take the base of the log, we raise it to whatever this number is, or expression, and then whatever is there goes here. And we dealt in the last section with how to go from one form to the other, and we even talked about how that might be helpful when solving particular problems. This is going to come into play again here because what we're going to be doing is solving equations and inequalities that have logs in them. And what you're going to find is usually when we want to solve an equation that has a log in it, we want to get rid of that log because it's very difficult arithmetically to deal with these. So the fact that we can write it this way is going to come into play quite often. Okay. So let's go ahead and start off with our first example here. Okay. In the last section we were dealing with evaluating logarithms. So like something like log base 8 of 64 or something like that. Okay. All we're doing here is making it an equation with an equal sign. So we want to solve log base 8 of x equals 4 over 3. So before we start, what I want you to know is there is a number that we can put in for x that will make this true. We need to find out what value that x is, and I'm not going to necessarily say the best way to do that is what we're going to do, but this is certainly a way that makes sense. What we have here is written in logarithmic form, right? What we have here is written in this way. So what you could do is you could say that the base is 8, answer is x, and exponent is 4 over 3. So to solve this and find out what x is, the first thing I would do is write it in exponential form. Again, hopefully you're taking notes here. If you don't have a pencil and paper handy, see if you can grab that, pause the video, come back when you're ready. That way you've got this worked out and you'll know how to do it if you see a similar problem on the homework. So if we want to write this in exponential form, the base goes first, that's 8. The exponent is the thing by itself here on the right, that's 4/3, so that's 8 to the 4/3 power equals, answer is this quantity here, that's your x. So 8 to the 4/3 power equals x. That's what we have. Okay? This is better, this is easier to solve because we don't have a log anymore. And we actually got that x by itself, all in one step. That's pretty good. So the only thing we need to figure out is, what is 8 to the 4/3 power? Well, there are lots of different ways to approach that. We could write this in radical form and write it as 8 to the 4th power, the cube root of that. But there might be an easier way to do this. What if we could break down 8? How does 8 break down? So we are breaking down the base here. We're breaking down the base. So 8 breaks down into 4 and 2. I'm borrowing room up there because I didn't leave myself a whole lot here. The 4 breaks down into 2 and 2. We've got 2 here. So 8 is 2 times 2 times 2. We could write that as 2 to the third power. Okay. So 8 is the same thing as 2 to the third power. So what I'm going to do here, I'm going to rewrite what we've got here, but instead of 8, I'm going to write it as 2 to the third power. This is still being raised to the 4/3 power. Okay. I have a bad habit when I write fractions. Sometimes I write them this way, sometimes I write them this way. It's still 4/3. Sorry about that. Okay. So, it might look like we just made this more complicated. But figuring out what this is now requires you to remember, what do we do with these two exponents? If we have something with a power raised to a power, we do what with the exponents? Multiply. We're going to multiply those exponents. Multiply exponents. So what is 3 times 4 over 3? Well, that's 3 times 4, 12, divided by 3, 4. So this is 2 to the 4th power. You can think of it as the 3 here and the 3 here cancel out. So 2 to the 4th power equals x. That's great, but it would be better if we knew what 2 to the 4th power was. 2 to the 4th power. That's 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 again. That's 16. So x is 16. And that's our answer. So, in order to solve an equation like this that has a log on one side, notice this side has a log, this one doesn't. Okay, we're going to get to examples later where there are logs on both sides. We'll deal with those a little differently. But if you've got a log on one side, your first step is to write it in exponential form. Okay, using this. Once you've got it in exponential form, you're probably going to have a number here that's not necessarily one that you would like. It might be a fraction. If so, take that base, break it down if you can. If you can write this as a number to some power that will help this be easier to figure out, that's better. Because what's easier to figure out? 8 to the 4/3 power or 2 to the 4th power? Okay. So, those are your steps there. So, if you're feeling good about this type of problem, what I'd like you to try is the first multiple choice problem that's right next to it in the notes. You'll see the setup is very similar. We've got a log with a base. We've got our variable here, which is n this time, and it equals a fraction. So your steps should be very similar to these. Go ahead, pause the video if you're feeling good. Try it out. See what you come up with. If you get stuck, that's fine. Just play the video, and we'll see what happened and get our answer for this one too. All right. I'll trust that you pause the video and you've got something. Maybe you got stuck somewhere. That's fine. Let's see what we got here. We're going to follow the same basic steps here. In order to solve this and find out what n is, it's going to be a lot easier if you write it in exponential form. So the base goes first. This is the exponent. And it equals n this time. And again, I don't want to figure out what 27 to the 2/3 power is. I could, but it'd be much easier if we took this 27 and wrote it as a number to a power so that we can get rid of this fraction here. So when we break down 27, that's going to be 9 times 3. And the 9 is 2 3s. So 27 is 3 to the third power. Okay? It just so happens that it's a number to the third power, just like this was 2 to the third power. Okay? So we're going to write 27 now as 3 to the third power. And I write that in parentheses just so it doesn't get confusing what's happening with the exponents. If I didn't write the parentheses here, and I wrote 3 to the third power to 2 over 3 power, you might think this is 3 and 2/3, like a mixed number. That's not the case. This is 3 to the third power raised to 2/3 power. Still equals n. Okay. The trickiest part of this entire problem might be getting from here to what comes next, because you've got to multiply 3 times 2/3, and if you've got this hang up that you're multiplying a fraction and you never had that down, you struggle with that, and you feel maybe embarrassed that you still might not know how that works particularly well, that's okay. It's fine. First of all, getting from here to here tells me you know a lot about logs. Okay, you knew to write it in exponential form, and then you knew to break down the base. Most of the problem is done at this point. But once you know you need to multiply these fractions, this is 3 over 1. And then you've got 2/3 there, and you want to multiply them together. You've got a couple options. You could multiply straight across. That'll work. Or you could try to reduce something on the top with something on the bottom. So if I just went straight across, this is 6 over 3, which is 2. If I were to do this, and notice I have a 3 on top and 3 on the bottom, those turn into 1s. This turns into 1 times 2, which is 2, over 1 times 1, which is 1, which is also 2. Okay, I don't want multiplying these numbers together to be where this falls apart for you. Okay, so either way, we know that when we multiply these exponents, we get 2. So this is 3 to the second power. 3 squared. So 3 squared. Please don't say 6. Remember, this is 3 times itself. 3 times 3, which is 9. So n is 9 here. N is 9. All right. So there's 2 examples of when you have a log on one side of an equation and you want to solve for that variable. Write it in exponential form first. Break down that base so that you can multiply those exponents easily, and it should be able to be solved from there. All right. So we've solved equations that have a log on one side. But there's something about logs. Sometimes they find themselves all over the place. If we look at this example, we're still solving an equation. And I know it might look a little intimidating at first. Trust me, we're going to make this work. We want to solve this. Notice that on both sides of the equal sign, we have a log. Your initial reaction might be to think, well, that's going to make it harder, right? There's a reason we started with these examples, and now we're doing it with this one. In your notes, it says, if there are logs with the same base on both sides, colon, fill in the blank. If you've got an equation you need to solve that has a log on both sides, and the bases are the same, which they are here, they're both 4s, what you can do for the very first step of the problem is something amazing. It's so awesome. I love solving problems like this because what you're allowed to do, you can take the logs and the bases that go with them, and you can cancel them out. If you're solving an equation that has a log on both sides that have the same base, you can just cancel those logs. You can just go, whee, and they're gone. That is totally allowed. That is valid in the rules of mathematics. But only if you've got logs on both sides. We could not do that here. Okay? But here, it's actually easier. Just get rid of the logs right away. And then write what you've got left. The log base 4 canceled out, so we have x squared over here. And it equals, we canceled this log out, we've got negative 6x minus 8. Now all you need to do is solve this. It's not a log problem anymore. The logs are gone. But it's still not a particularly easy problem to solve because we've got that x squared in there. Since we have this x squared, this is going to be a quadratic. So in order to solve a quadratic equation, usually you want to get everything on the same side of the equal sign. And we want to keep this x squared positive, so let's move this stuff over here. So we're going to be adding 6x to both sides. And I'm going to go ahead and add 8 to both sides on the same step. Okay. So on this side, this is x squared plus 6x plus 8. You can't combine any of those terms. They are not like terms. This has an x squared, this has an x, this doesn't have an x. So we'll just write it that way. X squared plus 6x plus 8 equals, these cancel out, and these cancel out. That's exactly what we wanted to happen. There's nothing left over here, so it's a 0. So we still need to solve this for x. And there are more than one way. There is more than one way to do it. I might see if this factors somehow. So what you could do is try and find two numbers that multiply to 8 and add to 6. And I've got my own way of factoring. I write this off to the side. If you use the X method where you write numbers at the top and bottom, do that. Okay, whatever you're comfortable with. Two numbers that multiply to 8 and add to 6. We've got 1 and 8. That's not going to work. Other numbers that multiply to 8, 2 and 4. We need the numbers to add to 6. Hey, 2 and 4. Numbers are 2 and 4. So that means I can write 2 sets of parentheses that equals 0. The numbers are 2 and 4. So that goes in the back. Our variable x goes in the front. So we've got x plus 2 times x plus 4 equals 0. Now it didn't say factor. It says solve. So we need to keep going. We need to know what values of x make this true. So what we're going to do, we're going to take each thing that's in parentheses and set it equal to 0 separately. So we've got x plus 2 equals 0 and x plus 4 equals 0. And we want to solve each of those for x. That should be pretty easy. Just subtract 2 from both sides here. X equals negative 2. Subtract 4. X equals negative 4. Okay. X equals negative 2 and x equals negative 4. So this has two solutions. There are two values of x that made this initial equation true. Not bad. Not bad. I want you to know that 90% of the work in this problem had nothing to do with Chapter 7. Had nothing to do with the logs. Once you knew those logs canceled out because of this suddenly became a problem from, I don't know what chapter that was. Was that Chapter 4? Where we solved the quadratic equation by factoring. Okay, this is from forever ago. You just have to bone up on that a little bit. Okay, but if you know the rule about logs, even if you just get to this point right here, if you show me that like on a test or something, that'll be worth something. Because that shows me you know one of the things about logs. All right, one more example. One more. We've got Multiple choice problem 2, the last problem on the front side of the notes. We want to solve this equation right here. If you want to do it on your own, now's a great time to pause the video. Come back when you're ready. Ooh, when I look at this, yes, there's something I want to do more than anything else in the world. It would be nice if I could just cancel those bases out, those logs. Can I do that here? Are there logs with the same base on both sides of the equal sign? Yeah. Whee! I love it. I love doing logs. This is great. Okay, so logs are gone. Let's write what's left. X squared equals x plus 20. All right, so we're in a similar place to where we were at this step on this one. We want to get everything on the same side because we've got an x squared here. This is a quadratic equation. Let's move everything over here. We're going to subtract x and subtract 20 this time. So this is x squared minus x minus 20. These cancel. Equals 0. Okay, so we need to solve this by factoring. You could also use the quadratic formula if that's what you're into. But if it factors, that's usually an easier way to do it. So I need two numbers that multiply to negative 20 and add to negative 1. Remember, if that's just a minus x, the coefficient, the number in front of x, is a negative 1. So we need numbers that do this. Numbers that multiply to negative 20, 1 and 20. Those aren't going to add to negative 1. 2 and 10. No, they're too far apart. 3 doesn't work. 4 times 5. 4 and 5. We need the numbers to add to negative 1 now. So one of these has to be negative. It's got to be the 5. So 4 and negative 5 are the two numbers that are going to work there. 4 and negative 5. So remember, once you get your two numbers that are going to work, that's when you can write your two sets of parentheses and set them equal to 0. 4 and negative 5. 4 and negative 5. Variable goes in the front. X. So we have x plus 4 times x minus 5 equals 0. And we want to solve. We want to find out what values of x make this true. So we set each of these equal to 0 separately. And solve for x. Subtract form. X equals negative 4. Hey, x equals negative 4 over there too. Interesting. And add 5. X equals 5. Okay. So again, two solutions, and that's because in our original equation in both of these problems, we had an x squared. Okay. I don't want you to think that every time you've got logs on both sides, that you're going to have to factor a quadratic. This could easily have been something like just like 6 or something. That would have given you an easier equation to solve for the rest of the problem. But I did want to give you a nice review of how to factor a quadratic, because I feel like maybe people have forgotten how that works. And that's something that's going to come back over and over again as you go through your mathematical career. So, now we've learned how to solve some equations that have logs in them. Some equations only have a log on one side. If you only have one log, your first step is to write what you've got in exponential form. Okay? Then you can deal with that. If you've got logs on both sides that have the same base, they'll usually have the same base. Get rid of the logs right away and write what you've got left. The two examples we've done here like that are probably more difficult than what you'll be expected to do on a homework or a test or something like that. They might even be easier than these. So by having these worked out and good to go, you should be in great shape for what you come up against later. Okay, that's the front side of the notes. The next video that you'll get will be for the problems on the back, and then you'll have a day to work on the homework for this section. So I hope so far that logs are treating you all right. If you have any questions, as always, shoot me an email. Glad to help you out, and we'll see you next time.